Afternoon, good evening. I'm the Vice President and General Manager of Open Ecosystem Team at Intel. You can find us all about us at open.intel.com. We have a beautiful podcast as well at open.intel.com/podcast. Please subscribe to it and let us know if you would like to be a subscriber to that podcast. We are always looking for wonderful speakers over there. I'm super happy here to be with Jesse. Hi, Jesse.
Hello, how are you? Good
I'm
to be
doing
here.
very well. Yeah. You want to introduce yourself?
Yeah, Jesse Hall, Senior Developer Advocate at MongoDB. I've been there for almost 3 years now and just having a lot of fun. I love creating content and educating developers.
That's wonderful. That's like, and I've been, as they say, once you are a DevRel, you're always a DevRel, no matter where you go. So I'm really happy that you're on the call. For the three people in the world that don't know what MongoDB is, tell us what is MongoDB.
It is a database, and that's the simplest explanation. Is a document database. So a little different than relational databases that you might be used to. Some people call it a NoSQL database or a non-relational database. Honestly, I kind of hate those terms because they are kind of confusing. It's a document database, and when you say non-relational, first thing that comes to mind is, oh, I can't store relationships in MongoDB, but you actually can. They're just stored differently. So it's a document database, basically like a JSON structure. And there is the flavor of MongoDB that you can install. It's open source. You can install it locally and run it wherever you want. And then we also have our cloud-hosted version, which is MongoDB Atlas.
Got it. Got it. And I like the way you explained it because anything which starts with saying it is not that, it is no sequel.
Mhm.
That's the wrong premise to start with right there itself.
Yeah.
Let's talk about what it is. That it
Mhm.
is a document database. It can store JSON structures. Sure, it can have relations. Sure, it have queries and all those things that you would expect from a database.
Yeah.
But calling it just a NoSQL database is like, yeah, I got a Swiss Army knife, and I'm only talking about the screw part of it.
Exactly. Yeah, and then like NoSQL, I actually would rather you call it not instead of not SQL, not only SQL, because you can actually run SQL queries, which a lot of people don't know as well. There's a SQL plugin as well. So there's so much that it can do. So yeah, let's talk about that.
Wonderful. Okay, awesome. Now, the title of this webinar is Let AI Be Your Docs, integrating GPT into your application. What's MongoDB got to do with that?
So, really cool feature, fairly newly released, is our vector search, and that enables you to use MongoDB as a vector database. The really cool thing about that is it's not a bolt-on to your existing database. You can have everything all under one hood, so that, for instance, if you wanted to hone in on the specific data that you want to search beforehand, because you've got all of your other data already there in MongoDB, you can actually limit your queries before you do the vector search, which then makes it so much even more refined and accurate on what it returns to you. And we'll kind of look at that as we go. But the really cool thing, again, like I said, is just all together under MongoDB. And that's how AI comes into it. And let AI be your docs. The demo today, we're going to showcase a documentation website that is going to search only our specific data. It's not going to rely on the LLM to maybe hallucinate. And so we're going to also learn how this integrates into our application, and we can use the same concept, same things to integrate it into any other type of application that you want to add an AI chatbot to.
So you're going to show an application that is relevant for that particular use case. But the
Mhm.
whole idea here is that concept could be scaled to whatever application, and hence integrating GPT into your application with like a OpenAI backend, or what are we looking at?
Yeah, there's several. I mean, any of the different backends that you can use today will be demoing OpenAI, but that can be swapped out for any other thing. You can even host your own and integrate that. And the premise here is that you can take this knowledge and use it in your own application and apply it to that. And also, we're not just implementing OpenAI directly into our application. We're going to use something called RAG, and that's going to augment what the AI is capable of, basically giving it extra superpowers to then return relevant data to our specific use case.
Got it. Well, OpenAI is sort of the LLM backend, which is a foundation model, and that can do some tasks for you, but it doesn't do everything for you. And I guess that's where RAG fits in.
Exactly. So RAG, a retrieval augmented
So
generation.
maybe
Yeah,
let's start with your slides because I have slides to set the
yeah,
context, right?
yeah,
Okay,
yeah, for sure, for
so let
sure.
me
Let's
bring
go
the
through the
slides
slides.
in. Okay, here we go.
All right. So basically, just want to give the audience like a background, very quick background on AI and how we got to where we're at today. So like in the early days of computing, applications primarily relied on analytics to make sense of data, and this involved analyzing large data sets and extracting insights. Which could then inform business decisions. And then, as computing power increased, it became easier to analyze these large data sets in less time. And that's when the first kind of AI evolution came with batch AI. So as computing power continued to increase, the focus then shifted towards machine learning. And traditional batch machine learning involves training models on historic data and using them to make predictions or inferences about future events and about how users might interact with our applications in the future. And the more data over time that you feed these models, the better they get, and the more we can tune them, the more accurate the future predictions become. And so, as you can imagine, this is really powerful because if we can predict what's going to happen tomorrow, we can make some really great business decisions today, right? So batch AI, as the name implies, it usually is run offline and on a schedule. And so it's analyzing historic data to make predictions about the future. And that is the problem with batch AI because it's working with historic data and it can't react to what's happening in real time, right? And so although there's some great industries that can benefit from this like finance and healthcare and different things, we also want to be able to respond to real-time things. And so this is where real-time AI comes in. And so this represents a significant difference here. The approach involves training models on live data and using them to make predictions or inferences in real time. And so this is particularly useful when we're trying to detect something like fraud detection. So, I mean, what good is fraud detection when the person that's defrauding you has already gotten away with it, right? So we need to be able to react to these things in real time. And then the last step, the step that we're at today in the AI process evolution is generative AI, and this is the approach that involves training models to generate new content. And so this can be images, text, music, videos, and it's not simply making predictions anymore. It's actually creating the future. And so we can see that this where we're at from where we started with just this basic analytics to now being able to see things or make predictions and things in real time and generate even new things is super cool. And fun fact, all of the images here were created by Dolly.
There you go. That's a beautiful example. That's a nice conclusion. So,
Very meta.
yeah, very meta actually. So, if you think about it, the way I'm groking this, I could take my customer profile information and maybe use that for batch AI. There may not be a necessity for doing a real time AI, although we could do real time AI.
Hmm.
When I am driving my EV, that's where I'm really looking at real time AI
Hmm.
because am I going left? Am I going right? What's car around me? I really on the fly need to make predictions in real time.
Hmm.
And then, of course, generative AI is where, all these multi-modalities that we are talking about. I guess another step that we can talk beyond that is AGI, automated general
Yeah,
intelligence, that I've heard, Sam Altman and all talking about is
yeah.
coming like in 2028, 2030 timeframe. Who knows? But that's sort of the element that they've been talking about too.
Exactly. Who knows? They may have already have it. It's just under wraps.
Yeah, exactly. Come November 2024, like voila, we got
Mm.
AGI, OpenAI now.
Exactly. Yeah, that would be the next step. Yeah, some people say it's scary and some say they're looking forward to it. So, hey, we'll see.
Well, ready or not, here it comes. I mean, how do we
Exactly.
embrace it? How do we be a successful user of it? How do we a power user of it? I think it's one of those quantum shifts, so to say, like, when computers got introduced, when internet got introduced, so things like that is such a quantum shift that we see, once every few decades. And I think that's how we are seeing it.
Exactly. That the question always comes up, is AI going to take my job? And I always say, well, maybe it could take some jobs, but most likely it's not going to take all jobs. I mean, think about, like you just said, the introduction of the computer. Did that get rid of jobs? In a way, yes, it got rid of some jobs, but it made people's jobs easier. It made us more efficient. It was a tool that we could then use. So that's the same thing with AI. It's a tool that's going to make us. It's going to help us become more efficient. Yep.
Fantastic. All right, let's keep
Mhm.
moving.
Yeah. So generative pre-trained transformers, we know this is the basis, the natural language processing models that we have today, like OpenAI. They can generate content. They can even do some complex reasoning, but we know that there's limitations to these. There was a knowledge. I think the knowledge has been kind of updated a bit, like what it was trained on, but there is a bit of a knowledge gap there. They can hallucinate. And here's the key thing: they don't know your data. They don't know the things that are in your database, the key things that you want to ask questions about, analytics and whatnot. It doesn't know that. And so how can we train? How can we get over these limitations? And sometimes developers will think, well, I want to train it on my own data. Well, that's one way you could go about it. But that's much more difficult, to train it on your own data. What we're going to talk about is augmenting what is already there to help us get to that point quicker.
So if we talk about a perspective here, there is foundation models like OpenAI, Llama, all of them
Hmm.
existing.
Hmm.
People could take that, say, no, I like it, but I'm gonna, first of all, though, like, or at least OpenAI is not an open source model, so I can't really take it and say I'm going to train it on my data. But you could
Hmm.
take something like Lava and say I'm going to train it
Yep.
on my data, but
Yep.
that requires extensive amount of compute processing power. So that's one part of it.
Exactly.
Second, what you could do is you could take the model and you could fine tune it, and that again still requires extensive amount of resources. And
Exactly.
then comes this part where you're talking about the RAG part of it. And before we jump into RAG, I was listening
Hmm.
to a podcast a couple of days ago, and they were talking about these LLMs. Hallucination is not a bug, it's a feature,
Hmm.
because LLMs are, the foundation models are so generic, and particularly without context of the data, that's the way they're supposed to operate. So
Hmm.
the only way to make them work for you is to augment the data, because once they have the context of your information, then they start operating appropriately.
Exactly. They're just doing what they were trained. Exactly. And it comes along with augmenting it with your own data, and also some prompt engineering. So that is a new skill that everyone is going to have to get used to. Prompt engineering. We have to do that.
Beautiful. All right.
Cool. Okay, so this is where we're going to get into RAG. The demo that I'm going to showcase today uses React. It's JavaScript based, but again, these concepts, they can be translated into a Python application or any other, whatever application you're running. The same concepts are can will apply. And so, what is involved in retrieval augmented generation? Well, first of all, need to understand what a vector is. And a vector is basically just an array of numbers. And you can think of a vector as a graph, right? So you have the different points in your graph, and these numbers represent those different points. And so we have the numbers; these coordinates are in an n-dimensional space, where n represents the array length. So, for instance, if we have 1536 is our array length, we have 1536 vectors that we can then use in that vector space. And so the vectors, these are also sometimes called vector embeddings or embeddings. And so that's what each one of these numbers are, is a vector. But how do we go about generating or getting these vectors? That skipped ahead too quickly. That we're going to look into vector embeddings, and we're going to use the OpenAI vector embeddings to create these. So in this example, a quick brown fox translates to this array of numbers.
And what's the logic behind taking, like, how does it get converted? Is there a logic behind it, or is there like a standard math? Is it a independent of what is the underlying vector database? Would a quick brown fox always be converted to that vector?
Well, it depends on the embedding model that you use as to what the embeddings would generate. There's different embedding models for different things. There's for text, for video, for music, etc. And so it really comes down to which embedding model that you use as to what it would then convert to. But what I like to use as an analogy is the next slide. Is if you go to a hardware store and you look for something, or any store, and you look for something and you ask an employee, where can I find light bulbs? They're probably going to say it's in aisle 23, bay 15, right? And so that is a two-dimensional vector. And so they're telling you in the store where to go. And you also find that they put products that are closely related together, right? So if you're looking for light bulbs, they're all going to be in that area in aisle 31, bay 25, whatever it is, instead of just spread out randomly all over the place. Another thing that uses vectors is in 2D and 3D is gaming. And so these coordinates are really just vectors identifying where things are at in the world. And we can even use these for collision detection. And my favorite, if you're a Stargate a fan, the gate is actually can be seen as vectors. And so the addresses to locate stargates in other galaxies, you can add 7 or 8 dimensions here, and it's almost like a phone number with area codes, where you have the different area codes, right? And it's basically like an address, and it shows you where we're at in this virtual space, like in the universe, right?
That's beautiful. Home
Yeah,
Depot, Angry Bird, Minecraft, and then
yeah,
Stargate. I
yeah,
think what a beautiful way to kind of do an analogy. So I can imagine the kids these days that are doing so many Stargate on all kind of games that they play, because their mind operates very much like a vector database, because they're always thinking in
exactly.
that n dimension. So I
Hmm.
suspect they will actually make a really wonderful workforce for us.
I think so. I think so. It relates to so many things if you think about it. Vectors are really not a tough concept to grasp. It's
That's
just
right.
it's a multidimensional space basically, and
That's right.
where things related to in that space. And
Right.
so again, what makes vectors so special? They enable semantic search, enable us to find things, and in simpler terms, to find information that is contextually relevant, and it's not just like a keyword match, right? And so these, again, they can be different data sources. It could be text, video, audio. All of these can get converted to vectors depending on which embedding model you're using.
So maybe one question I have is, if I take the quick brown fox and I'm using the embedding model for text,
Mhm.
would that be stored exactly same in a Mongo database versus
Mm.
another database?
Oh, yes, yes, actually. Um, eh, the database is going to store whatever is the output from the model that you're using. And so you're using the OpenAI model, for instance, you're going to basically just store those array of numbers in the MongoDB database. There's no alterations made on the database side. It's just whatever came
Got
from
it.
your LLM that you're using, that's what we're going to store.
I see. Okay. All
Mhm.
right.
Yeah, perfect. So here's the encoding part. So how do we get these vectors? The encoder defines how the information is organized in that virtual space. And so again, this is not anything MongoDB specific. Whatever encoder you're using, it's defining how these things are organized in that virtual space. Again, there's different types of encoders. The most popular ones kind of come from Hugging Face, OpenAI. There's many others. You would want to do research on whatever thing you're trying to encode and find the best encoder for that. And all of that is agnostic from MongoDB. Whatever encoder you want to use, it's going to store it in MongoDB.
So all you're saying is the customers bring their data and encoder, and whatever is emitted out of it is stored in the MongoDB database, independent of how it is generated, and then it's a vector stored
Mhm.
there essentially.
Exactly.
Okay.
Yep.
And what should be the considerations when developers are trying to choose an encoder? As you said, there is one by Hugging Face, there is one by OpenAI. Let's say I'm
Mhm.
using an OpenAI model. Should I be using?
So if you're using an OpenAI model and you're converting text, for instance, the 802 model is basically the standard right now. Actually, they just came out. There was a new announcement I read earlier this morning. There's a newer model now, but basically, yeah, that you would use that model, and the output of that would then be stored in MongoDB. And again, going back to why it's so great in MongoDB is that, let's say you have an existing collection. Let's say it's a book library. You've got all your books in there and it's have all of your data. You've got your titles, descriptions, authors, all that sort of stuff. And you want to create embeddings for the description of the book so that we can quickly search book descriptions. You can then include those embeddings directly in that same document, so that then we can say, I want to, let's say on the front end, we're searching for a specific book, but I want to limit it by the publication date. So we'll limit that initially without doing any vector search, and then do vector search on the resulting query. So it really helps us to hone in and refine our searches even before we get to the vector part.
And that's kind of, augmenting your query essentially with that specific domain context. Okay, perfect. Got
Exactly.
it.
Exactly. Yeah. Cool. So, so the RAG workflow. So we have vector search capabilities can augment the performance of the GPT and provide that memory or ground truth. So we have our things. We have whatever it might be, text or video or our documentation, whatever it is, PDFs, and we want to embed that. So in our example today, we're going to use LangChain to help facilitate that, but it's not necessary. It's just a key thing that kind of helps in this specific use case. We're going to use LangChain to take those documents, and we're going to then go up to OpenAI and create those embeddings and then push them down to our vector database. So that's that first initial thing. We're creating embeddings for our documents, storing that in MongoDB.
And so you're taking like a lot of private knowledge sources, which is basically what your context is.
Yes.
Use that LangChain, and LangChain because LangChain is basically an LLM wrapper. And so you're using the OpenAI pluggable LLM model over there, using their encoder to encode those documents and store those embeddings into the MongoDB database.
Exactly. Yes.
Got it.
And the key point here is the private knowledge source, our private data that we know the LLM has no idea about. So,
Correct.
yeah. So we're embedding those, storing them in our database. That's step one. Step two is the user is going to interact with this. They want to ask questions about the information that's there. So the user, we then go back through LangChain with their question, their query, their just human text, and it goes up to OpenAI to create an embedding. Because so we have our embeddings, our virtual space for our documentation over here in MongoDB. We have the user's human natural language. We have to convert that into an embedding as well, so that we can then search that virtual space, right? So the human readable text goes up to LangChain, to go through LangChain up to OpenAI, create the embedding, and then compare that with what we have in our MongoDB database to see what is the closest results, and then that way we can then send that to the LLM to give us an accurate response to the question, whatever it might be.
And the reason you convert the user interaction NLP to an embedding is because then it's going to be in sort of the similar vector space, essentially in the same semantic space.
Exactly. Again, go back to the game world. We're in this game world. We've got all these things in our MongoDB database all over this virtual world. The person is asking a question about all this stuff. We have to get them into the world. So to get them into the world, we have to convert their question into an embedding as well.
Yeah, I mean, it reminds me of the Star Trek phenomena. Scotty, beam me up. Now I'm in the planet. Now I can actually operate in the planet. Yeah, so this is Scotty, beam me up.
Nice, exactly, perfect.
Okay.
So the RAG tech stack that I'm going to demo today, we're going to use Next.js, OpenAI, LangChain, the Vercel AI SDK, and MongoDB. Again, the concepts here can be translated into any other tech stack. This is just what we're looking at today.
That's beautiful, actually, because several years ago, the meme stack used to be quite popular. Where you will talk about, let's see if I remember correctly, MongoDB, Express, Apache, and then Node.js.
Yes, Node.js, and
sort of that used to be the stack. So this is sort of the new meme stack, particularly from the AI perspective.
Yeah. There's mean and mern. So the main difference is there. Mean uses Angular, and and mern uses React.
React.
That's
Okay, got it.
just the
Mean
front
and
end
more.
difference.
Okay. Okay.
Hmm.
Have you folks created a new name for this kind of a stack so far?
I don't know. See, NOLV, that doesn't really create anything. No.
MOLN, Moln. I don't know.
Yeah,
Fair enough.
we'll have to think about that.
Yeah, look, if you think about, I'm sure, well, this is a prop to Peter and Matt. So hi, Peter and Matt.
Yeah,
Let's come up with a creative name for this.
yeah.
That would be sticky because when I was growing up, Mean and Mern, like Mean at least was particularly Mean and Lamp were
Mhm.
super popular. That's
Yes.
how that took the world by storm.
Yes, and honestly, they still are very popular stacks, and they're very
Oh yeah,
relevant even today. But there's just in the JavaScript community, there's so many frameworks. So there's a stack for anybody that,
that's right.
whatever use case you're looking for, there's a
Okay,
stack
we're
for it.
gonna focus on let AI be your docs today. So I think
Yeah.
that's fantastic. Let's do
Yeah.
it.
So, okay, so that's kind of the end of my slides. I think yeah, so this is what I'm going to show you next is kind of based on a workshop that is a self-paced workshop. So if you wanted to go to mdb.link/vs-demo, you can actually go through this workshop on your own. But we're just kind of show you the highlights of this workshop as we go through this. So let me go over to actually to VS Code. And I'll just kind of give you a quick run through of this application that we have set up here. So this is a Next.js application, and let me just go to the package JSON and I'll show you what's installed here. Show you like the basics. So AI is the Vercel AI SDK using .env just to get our environment variables, LangChain, MongoDB, and then Next.js and all the React stuff. So pretty basic stuff here. Pretty standard in the JavaScript ecosystem. And what we're going to do first off is we're going to create our embeddings. And let me just show you what we're going to create that from. So in the workshop, we have some assets and some fake documents. And so what I have in here is documents that you would see on like a JavaScript libraries site. So let's just go to the README here. These are fake documents that I actually had ChatGPT help me create. And so this is for the fancy widget JS lightweight JavaScript library for whatever. Like, I don't know, ChatGPT came up with all this stuff. So we're going to create embeddings from these fake documents and then search them and ask specifically questions about what is in these documents that we know OpenAI has no idea about.
Right, because
So
OpenAI does not know about this. So by integrating this as part of the RAG pipeline, then it will start understanding that context and again do that semantic search because it's going to be in the similar area.
exactly. Let me actually, before we do that, let me just run this site real quick, this app, and show you what it does before we do any embeddings or anything.
Got it.
Let's get
So
this
right now,
running.
this is just raw using LangChain OpenAI backend.
Exactly. So very, very simple site. We've got a little box down here. I can interact with it. Let's say hi. It says, hello, how can I assist you today? I'm going to ask it, what is fancy widget.js? Fancy widget is not widely known or
Yep, that's the
recognized
standard answer
JavaScript.
I've seen. Yeah.
It has no idea. It has no
Yeah.
idea what it is, right?
Like, what are you
So
talking about? Exactly.
yeah, no idea. Now, I'm glad that it didn't hallucinate, actually, because it could have hallucinated and said that, could have made something up, but it actually said it doesn't really know. So
So this is
what
just straight raw OpenAI backend.
exactly? I'm just communicating directly to OpenAI right now, and
Okay.
nothing else involved.
Got it.
So what we're going to do is we're going to create our embeddings from our fake documents. To do this, we're using Node.js, the file system. We're going to import a bunch of stuff from LangChain. So we're going to import a text splitter. So first of all, we need to split our documents into chunks.
Right.
And there's different strategies for doing this, but basically we need to split it up into chunks that the embedding model can then accept and then turn into to an embedding. And we'll talk about that a little bit further down here.
Okay.
We're also going to use LangChain's MongoDB Atlas Vector Search. So this is a built-in feature of LangChain that uses MongoDB Atlas Vector Search. And then we're also going to use LangChain's OpenAI embeddings. And then, of course, we're pulling in the MongoDB client.
Okay.
So that's the basics here. This block here, we're connecting to MongoDB. So we are bringing an environment variable to connect. We're connecting to the docs database, the embeddings collection, and then we're going to pass this collection on down a little bit further.
Okay.
The next part here is we're grabbing our fake documents. So we're going into that directory, grabbing our documents, reading the documents, and we're just going to console log the file name so that we can see that in the console when we run it. Then we're going to loop over those files. We're going to pull out the content of those files, and then we'll just console log that we're currently vectorizing this
Right.
file.
Right.
And then this is the splitter part here. So we're using the recursive character text splitter from LangChain. We're telling it that it's Markdown, and then we can specify chunk size. So because it's Markdown, Markdown inherently has its own sort of hierarchy within Markdown. You've got
Correct.
headings and paragraphs and whatnot. And so LangChain has this all set up for us. It's so helpful. That's why I'm using it, because I don't want to write all this stuff on my own. LangChain knows that this is Markdown. It knows where to split it. Now, if, for instance, a paragraph is too big, then we're telling it what chunk size do we want to limit it to, right? So again, there's no right or wrong answer here. It's kind of dependent on your use case.
Got
So
it.
you kind of have to tweak these numbers on your own as to what chunk size you want to set. And then you can also have an overlap. So that is helpful in retrieval as well. If there's an overlap from this chunk to the next chunk, we have a little bit of context between the chunks.
Got it.
Again,
So because
things that we can.
Markdown already has its own structure,
Mhm,
so it just follows that structure. But let's say in a H2 heading, a
mhm,
paragraph is 1,000 characters, so it's gonna split it into two chunks of 500 each, because
mhm,
that allows you to still place them collocated, but
exactly.
good enough so that it's easier to search.
Exactly, and there's a bit of that overlap, so you kind of get a little bit from that chunk, a little bit from the chunk ahead of you, and you've got that a little bit of extra context.
Got it.
If you set it, and then you could set it to 0 if you wanted as well.
Yeah.
So then we got our output. We get our documents here, and then we're going to use the MongoDB vector search from LangChain and let LangChain help us out. We're going to give it the output of our documents. We're going to create a new OpenAI embedding. We're going to tell it which MongoDB collection to save it to, which index name. We'll talk about indexes a little bit later. We're going to tell it the text key. So in the document that we insert to MongoDB, where do we want to store the text and where do we want to store the embedding? So I'm going to call the text key text, very unique, right? So in MongoDB, we're going to see a text field and the chunk of text that we've embedded. And then the next field, I'm calling it embedding. We can call it whatever we want. And the embedding field is going to show our vector embeddings.
Got it. Got it. So it's basically, once the document has been split up into chunks, is storing all of that information, because that's where the splitter is coming from. It just puts all of that into these embeddings.
Exactly.
Okay.
Exactly. And it'll make a little bit more sense once we run this, and then I'll show you in the MongoDB dashboard what it does.
Okay.
So really, it's less than 40 lines of code, and it's going to split all of these up and store them in MongoDB.
All right.
So let's close this server and let's run npm run embed, and this is going to loop over our documents here, and there it goes. It's vectorizing each document,
Okay.
and we're done. So pretty quick. I mean, it wasn't a whole lot of documents, but
Yeah.
it's very fast. Now let's go over to Atlas, and let's see. So this is MongoDB Atlas. I'm going to this is my database, go to Browse Collections, and we can see docs and embeddings. That's what we had specified before, that we want where we wanted to store it. And so by default, we get an ID for every document that we insert, but here's that text field. So text field is that chunk of text that we split.
Right.
And then the embedding is this array of 1,536 vectors. So just
And that's the number you mentioned in the very beginning of the call as well.
Exactly. Just a bunch of
Right.
numbers. Yep. And so that's what got inserted. And then we also have this LOC that is an object, and then lines. And so it's telling us which document it came from, which line in the document that it came from.
Got
So
it.
this, for instance, is from lines 1 to 16. And so this is just some extra metadata that we can then, possibly use down the line to help us out.
Got it.
But basically, again, MongoDB is a document database, and this fits very nicely. Vectors and embeddings and everything fits very nicely into this document structure. And so we're just taking what the LLM outputted and storing it in MongoDB. That's all we're doing at this step.
Got it. Got it.
Yeah.
Beautiful. And by the way, I just saw a message in the chat. It's a hello from Nick. And
Hey,
Nick
Nick.
and I used to work together actually back at Couchbase. So what a beautiful hello. Hello, Nick.
Yeah, Nick's great.
He's awesome.
Yeah. Okay. Awesome. So we've got our stuff in MongoDB. We've embedded our private data, sorted in MongoDB. The next thing that we need to do is create an index so that we can search it. So we're going to go up here over to indexes.
And this you're all doing within the Atlas user interface.
Exactly. It can also be done in the CLI. There's various different ways to create indexes. This is just the GUI way, right?
Okay. Okay.
So go over here to create index, and actually, whoops, 1 second. Search. All right, there we go. Sorry. Create index, and then I'm going to use the JSON editor, and I'm just going to copy and paste an index we're going to create here. But we're going to specify where we want the index to be created. This is the only database that we have in here called docs and the embeddings collection. And then this is the index. So we're going to, is this large enough? Maybe.
Yeah, no, it's good. It's good.
Okay. So the key here is this fields part here. We're going to tell it which fields to index. So we're going to index that embedding field that we just created.
Okay.
And we're going to tell it the dimensions. How many dimensions are we looking at here? So 1536. This is specific to the embedding model that you use to create these embeddings, right? So the embedding model that I used for this creates 1,536 embeddings. So that's what I set that to. And then some similarity. When we do a search, there's different types of similarities that we can use. There's cosine, there's dot product, there's Euclidean. And so for this instance, I'm going to use cosine. And the type is KNN vector, so K nearest neighbor vector search.
And what defines the similarity? How do you pick the right similarity?
So that, again, kind of goes back to use case. So actually, let me see. In here, this is the workshop. In the workshop, there's a nice little, nice little diagram here showing the different types of like, this is a virtual space, basically, and you've got, your different marks here. And if we do a search, whatever you're searching for shows up here, then maybe that's closest to 1, maybe it's closest to 4, to 3. But in Euclidean, it will use the closest ones, whether it's positive or negative, basically. But cosine, it's going to find the closest on the same side of the vector.
Got it.
So that would show those.
It really depends upon how your embeddings are stored and what you want to search upon.
Exactly. Very much use case specific. Yep.
Okay.
All right. So let's go back to. So we're going to create this index on our collection here that will allow us to then search, and that. And this just takes it shouldn't take very long. There's hardly any documents there. And the next step that we can look at then. Let me go back to VS Code. We did our embeddings. The next thing that we can look at is how this is laid out. So again, this is Next.js, and so we've got some different API routes here. This is the standard chat route.
Okay.
So in Next.js, this runs on like a serverless, like a Lambda function, basically, is what this is.
This is AWS Lambda functions?
Exactly. That's basically what this is in the back end. Yep.
Okay.
So what we're doing is we're taking in the user's message, and then we're streaming that to LangChain, creating the OpenAI embedding for that user's message, and then we're sending that to the LLM. Now this is the default that we used a minute ago that didn't have any RAG or any kind of augmentation, basic stuff.
Right.
So what we're going to do here is, let me uncomment this part. We're going to add to it. And
so now we're going to inject our context in there.
Exactly. So what we're going to do here, first off, is we're going to take we're going to pop the last message out of this the messages is actually an array of messages. It keeps track of the entire message history.
Right. Right.
So we're going to pop the last message out and then pass that to a new route that I'm going to show you in a bit here. That's going to actually do our vector search. When we get our vector search results, we're going to put that into a template. And this is where prompt engineering comes in. So
Hmm.
here we're saying you're a very enthusiastic, fancy widget representative who loves to help people. Given the following sections from the fancy widget documentation, answer the question using only that information. I'll put it in Markdown format. If you are unsure of the answer and is not explicitly written in the documentation, say, sorry, I don't know how to help you with that.
So you're explicitly telling it not to hallucinate, that only you look at this information, but you
Exactly.
know based upon the documents that are provided to you.
Exactly. Perfect. So we're giving it that instruction first off, and then we're going to stringify our search results, and we'll go through that in just a bit here.
Yeah.
And then we're also passing in the original question that the user asked.
So that's part of the entire template that goes to the OpenAI backend.
Exactly. So we pop that last message out of the message queue. We're going to pop this template back into that same position in the message queue, and then continue on what we normally do, and just
Got
send
it.
that
Got
to
it.
the LLM.
So before it goes to your OpenAI or any LLM, you
Mhm.
are doing that prompt engineering, injecting that context, and in that context, in that template, you basically added whatever was asked along with the context, so that now it goes to the OpenAI backend and does the search appropriately.
Exactly. Perfect.
Okay.
Yeah. So let's look at the actual search functionality. So that's broken out into this the separate function here. And so what we're doing here is connecting to our MongoDB database, and then being passed to this is the user's question, right? And then we're connecting to the MongoDB database. We have that question, and this is where we're going to again utilize LangChain's MongoDB integration for vector search. So we're going to use the same model that we used for the embedding. That's important here. We're using the same model that we use to create our embeddings for our private data to create an embedding for the user's query.
I
And it's
see.
important to use the same model
So
because
far we have done for the docs that were integrated into the MongoDB. Now we are doing the same thing for the NLP request coming in from the user.
exactly,
Okay.
exactly. And the importance of using the same model to create those embeddings is that if we used a different model, it would kind of mess things up. They're not really in the same virtual space. It's kind of, the results wouldn't be great if we didn't use the same model. So that's an important thing. And then
That makes sense.
just taking out any new line characters, nothing there. Also, just telling it which collection to search, which index. Remember, we created that index.
Yeah.
I
Yeah.
just named it default, left it the same. Telling it the text key and the embedding keys, so that it
Yeah.
knows use the embedding key to search in the vector space, and then return to us the text key. That's
Yeah. Yeah.
what it's going to do. And then here's our retriever, where we're going to then take that vector store and do that search. And what we're using here is something called maximum marginal reference to search for. And then we're telling it how many initial documents or embeddings to fetch. So we're going to say get the closest 20, but then only return to us 0.1 of those, so 10%. So it's going to actually return 2 results, and then that allows us to kind of fine tune the accuracy of our augmentation here. And again, there's nothing set in stone with these numbers. This is something that you kind of have to mess with and tune to your own personal use cases.
Got it.
Yeah. So it's going to return those results and pass that back to that function, that route that we talked about initially, and inject that into the request to OpenAI.
Okay.
Cool. All
Sounds
right.
great.
So
Let's go.
let's go back into the terminal and let's run this dev server again. And go back to the docs site, and let's refresh this. So now, if we ask it, what is fancy widget.js? Cross your fingers. Hopefully, let's see
We'll find out.
what is fancy widget.js. Hey,
There you go.
fancy widget is a modern lightweight JavaScript library. Nice. So I also have, let's see, let's go back over here to our assets, and I've got some sample questions. So we could say, how do I install the fancy widget library? Ask that. How do we install it? Again, it's
So
going into
now is
documents.
digging into that vector database that we
Mhm.
created and bringing that context in. Let's answer something about, is fancy widget library cool? Like let's answer like a random question. See how does it answer that? Does it really?
See, yes, it's a modern lightweight JavaScript library.
I guess modern lightweight JavaScript library makes it cool.
Yeah, but if we ask it something like, "Is the sky blue?" Ask it that. Sorry,
I
I don't
don't
know
know how
how
to
to
help.
help with that.
Okay, okay, okay. So help me understand this. Is the sky blue? Is it only finding the information in the context? And if it's not in the context, it's not even going to the backend?
Well, it is going to the back end. It is searching. It is looking for context. So what's happening here is there was no context found, and so what was returned to our route was an empty object.
I see.
And so then we're telling OpenAI to if you don't have any context, then just say I can't help you with that.
Okay. So
And this
if you
kind of
don't have any context, then you're not passing anything to OpenAI at all and just returning back from there that, oh, I don't know how to help with that.
exactly, and that
Got
kind
it.
of helps with maybe users nefariously using your chat bot to ask
Yeah.
questions that it's not relevant to. So it's kind of it can help you with that as well. So
Yeah. 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 And this reminds me of the recent like New York Times sued Microsoft, saying that
mm,
hey, OpenAI should not have access to the data because it's digging into the data behind paywall.
uh,
So it's saying you could potentially go to OpenAI and say, what does New York Times think about this article? Blah,
mm,
and show me what the first paragraph from the article is. Show me the second paragraph and third paragraph,
uh,
because all of that information is fed into there and is behind the firewall. So I see the question here basically. But
mhm.
if we were to say that we will give you that information only if you are a New York Times paid subscriber, then would have said, I can't help you or I can help you, kind of a thing.
Exactly. Yeah, exactly. It's a way to protect your data as well as kind of protect your the use of every question that you ask is going to cost you some money to go to the LLM and to search for and all of that, and sort kind of protects you as well. So
Yeah, yeah, yeah. But I mean, that kind of goes, it's not an easy problem to solve because it's also about democratizing AI, right? How do you
mhm,
bring AI everywhere? How do you make it accessible to everywhere? If you start charging, oh, give me like 3 bitcoins or whatever, points zero
exactly.
zero 0.007 Bitcoin, if I were to answer this question, kind of a thing.
Yeah.
So,
No,
go ahead.
well, yeah, I'm just going to say this is a really, really simple example, and hopefully helps you kind of wrap your mind around how it works, the basics of how it works. But with MongoDB, this can scale infinitely, and that's the really cool thing about hosting this and having this on MongoDB is because like you can get started for free. There's the completely free tier, no credit card required. It's perfect for prototyping and testing things. You can have a dedicated cluster which you pay a certain amount for every month, no matter what you use. But we also have serverless instances where it's a pay-as-you-go type thing, and it auto scales for you. And then we also introduced search nodes. So if you have a huge search needs and that is kind of bogging down your main system, we can actually separate that search functionality out to its own separate node, and you can actually even have multiple of those. So the scaling and efficiency of this on MongoDB is really infinite.
That's awesome, actually.
Yeah.
So we showed an example of how to use this in a React kind of an application.
Yeah.
But the whole idea here is integrating GPT into your application. What other libraries this is possible for? What other languages this is possible for?
Yeah, so LangChain specifically was first created for Python, right? So this is you're going to see a lot of most use cases that you're going to see is going to be Python. I'm a JavaScript person, and I love that ecosystem, and so that's why I went this route. It's gaining a lot of popularity in JavaScript, but LangChain specifically Python. But there's also other integrations with Java and with I don't know if there's got to be an integration for every language out there, but I'm not the authority in all of those different
That's
languages.
fine. No, because like a couple of weeks ago we had a deeper conversation on LangChain for J, right
Mhm.
on this webinar itself. So I know there is a very deep effort that is going on for LangChain for J,
Yeah.
and in AI space, Python is definitely the dominant language in
Yes.
that sense. So it's good to see. But I think the point here being developers are building their application using Java,
Mhm.
Go, Ruby, all sorts of non-Python languages.
Yeah.
So that integration is something that they will have to kind of figure out how do they make it work.
Exactly. I mean, just to host a backend AI server and having to use Python, that eliminates a lot of developers, and every developer kind of wants to uh, get started in AI, and so yeah, I'm sure that there's going to be libraries for every different language to assist with that, and
That's right. That's right.
yeah, for sure, for sure. But
And
again, the key concepts, they're the same no matter what language you use. The key concepts is the same. You're gonna talk to that AI, and you'll inject your custom data, get some prompt engineering going to help it along the way, and the key concepts are the same.
right, right. I
Yeah.
think that's really the bottom line here. That the
Hmm.
key concepts are very much alike, and the beauty that MongoDB provides over here is it can scale infinitely. Because today you may be using the free tier, but then if you want to grow it, then go serverless route, or create those search nodes as you talked about, or
Hmm.
just keep using Atlas and it'll just grow and scale from there.
Exactly. And again, the key is also you have your data in your database all together. And so before you're even doing a vector search, we have Atlas search, which is a keyword search. Basically, you can do fuzzy search and all kinds of different things like that. But we can also use aggregation pipeline to aggregate your data before we even get to that vector search stage, so that we're really refining and honing in on the thing that we're searching for, and before we send it to the LLM, which some of the other bolt-on vector databases don't have that same advantage. So that's why keeping it all under one roof is so beneficial.
I think that's a very important point because your business data could be
Mhm.
sitting into MongoDB itself in addition to the vector database. So you have that, high bandwidth connection between that. So you go in, you do your query in the MongoDB database, then you do the vector search, and then you do the prompt engineering, and then you send the data over to LLM. So you've
Yeah,
already done a lot of refinement already by the time you get to the LLM. So really making it more contextual aware.
exactly. That's the key. Yeah.
Beautiful. I think we are almost getting to the end. And where can do you mind flashing that link for the workshop
Yeah,
once
yeah,
again?
yeah, for sure. See, that is here. There it is.
And this is where people can follow this along as a workshop.
Exactly. You can go to this link and you'll see the workshop, and you can just go. It's a self-paced workshop. You can go through it and set up your own vector database.
Beautiful.
Hmm.
I'm gonna hide this here for a second. Jesse, I really enjoyed this conversation. Is there anything I should have asked that I didn't ask today about MongoDB or vector search?
The key thing that I find that most developers don't realize that MongoDB is more than just that database, right? There's so much more to it, and really kind of dig in and see all these extra features that get the most of it. We also have a VS Code extension, MongoDB VS Code extension. Use that; it helps you. A lot of the things, are actually everything that I did today in the UI on the website, it can be done in the VS Code extension. So
Excellent.
yeah, yeah. So many things, great things that we're working on. Again, I have so much fun working at MongoDB and helping developers with their data needs. So I think we covered a lot of stuff with AI and RAG and all of this. So yeah, I just happy that you had me, and I think it went well. Yeah,
Thank you very well. No, I really enjoyed the conversation as well, and hopefully the folks that are listening to it also enjoyed it too. Thank you, Jesse. I really enjoyed the conversation once again, and hopefully people can follow that link for the workshop. What I would request is when this is already happening live on LinkedIn, so
yeah.
just drop a link to
Oh
the
yeah,
workshop in the LinkedIn comment so that developers can follow along.
I'll do that. I'll do that right now.
Awesome. Thank you,
All right.
everybody. Bye bye.
All right. Thanks. Bye.